Is that a custom token engineering jacket? Or?
Yeah. So this is a cycling jersey because I don't know if I told you how, but on September I'm going to do a cycling record here in Brazil. I'm going to cross north from south. It's going to take 28 days. There are a lot of sponsors there. There's Token Engineering Commons. There is also a Berlin Cycling Shop. There is Block Science. Also CAD.
That's awesome.
Yeah. There is also a Brazil map here. I mean, if you want to just... What, Xavier?
Are you ready for the journey?
Yeah, by the way, I'm taking an airplane to the Amazon tomorrow because I'm going to do 3 to 4 weeks heat acclimatization because it's super hot in there, 38 degrees Celsius all days. But yeah, I'll keep you guys posted. If you guys are interested, there is a form if you guys want a jersey. It's going to be the most crypto cycling jersey that there is.
Also from good projects.
So yeah, I think that I mean there is a new Thiago is here. Thiago did contact me last week through LinkedIn, and I thought it was a good idea to include him so that he get to know you guys and you guys get to know him. He's sort of getting immersed on the ecosystem too, so I thought why not also include him. So Thiago, just to contextualize you about this slot, this is sort of a mentorship slot about token engineering. Xavier and Austin, they are getting immersed on the ecosystem, get to know how the technology that is being used, and also about some of the methodologies that we use for designing systems. The name of this program is what we are calling being paid to learn. So the idea is that Xavier, Austin, and also Tex is essentially getting paid in order to learn all of that because there is a severe lack of people that, let's say, can make use of critical sense in order to know what the application platforms need in order to design sustainable systems and so on. We are doing those weekly sessions. We have sort of a template. So we usually start because every time that there is a new person, we do a very short introduction hobby. So maybe you could drop 1 minute or 2 minutes about yourself, Thiago, so that people know you.
Sure. Hi, everyone. I'm Thiago. I'm now in Lavras, Minas Gerais, studying agronomy and economy. I work with Blockchain Research Institute since 2019. Especially with studying blockchain and its applications in ecology and the agribusiness. And what else? And so I'm studying now, restarting to study data science and programming and this sort of things I'm doing. I just started an MBA at USP for big data and artificial intelligence, and I believe that's it.
Yeah.
Nice to meet you guys, and it's a pleasure to be here. And I hope to learn with you a lot and contribute when and where I can.
That's very cool, Thiago. And by the way, I'm going to drop some words about me. I also studied at USP. In case I did physics, I was an atmospheric physicist there. Just so you get to know, I'm a research engineer at Block Science, which is essentially a design and research firm for crypto economic systems. There is a long story. We're going to know each other with time. But Xavier, maybe you could drop 30 seconds about yourself too.
Hi, Thiago. I'm Xavier. I'm from Recife, the northeast of Brazil. I'm a physicist. I also studied in USP I did a master research in experimental particle physics, and now I work with programming and physics teaching, and I'm new in this area, and I'm studying mentored by Danilo. Nice to meet you.
Yeah, and Austin, maybe you could also do a 30-second intro.
Yeah, hi, Thiago. I am in Calgary, in Canada. I studied physics and music. Right now, I'm working with a company called Longtail Financial, and they're doing some modeling using CAD and other token engineering. So this is still pretty new to me, and hopefully we get to know each other.
Yeah, so a great deal of the topic of this slot is that, let's say, I don't know if you know the token engineering scene, but it's really about, let's say, doing modeling and simulation so that we can develop more sustainable systems and so on. And one thing about the program is that, let's say, the idea is that 80% of the time of the mentorees is really to, let's say, to participate on the token engineering research groups and courses and so on, to get immersed, to connect with each other. But at the same time, we are going to use a project called @GitHub, which is about connecting sustainable farmers to DeFi. And we're going to use that as a case study. So Raul here is one of the founders of @GitHub. And Raul, maybe you could do a, let's say, 20-30-second intro about yourself and another 30-second about @GitHub, and then we could get started.
Okay, hi, I'm Raul from Spain, from Madrid. I'm industrial engineer, programmer since 10 years ago, blockchain developer since 2017, and co-founder of Ethica. With basically connecting guild farmers with actual farmers, allowing them to have better credits that not even the existing financial system can provide them with DeFi.
Yeah. We're going to see a lot, and I mean, maybe on the end of this session, we're going to have the opportunity also to see some of the internals of how the economic dynamics of @GitHub works. So just to get on board, started on this slot, on the template for this slot. So we have done our intro round, and the next thing that we do is to, hey Dan. Hey Dan, we have a new member here on the slot, Thiago Rossi. Probably you can see the intro on the video afterwards, because we are recording the videos and we are putting on YouTube so that we can get it later. But we're now moving to the section that we ask ourselves, for example, how the last has been, what we have learned the last week, or maybe something that we have noticed, or some event that we got to know. It's really about updating ourselves and sharing, let's say, our knowledge and so on. So perhaps Danilo could start with that. I mean, what have you learned last week, Danilo? By the way, you are mute, Danilo.
Oh, I was talking to myself. I just arrived in your city, Porto Velho. Not your city, but your state. I was in an Amazon expedition without internet, so I was learning different things, mostly about work, I would say, the importance of work, and about relationship, and about like when I mean relationships, how we interact with not only love relationships but all kind of relationships, and also where is the true source of inspiration usually comes from. So I was deeply in the forest, sleeping on a how do you call that, net? How do you call that? On a hedge, on a boat for a week, going through different communities, doing different kind of works, and it has been a very blessing experience. Basically, I would say that I was living, like I was practicing, let's say, all this complex, like, all this theory about complexity, about relationships, about ecosystem, about human beings and interaction. I would say I was practicing that live with a lot of Indian communities. So yeah, that's that's how I'll be my week. Not something that is related to to modeling, but I would say like it could be like soul modeling. You know, how to model our heart, how to model our own environment, so that we can bring the best of ourselves as well.
By the way, guys, Danilo was talking about relationships and so on. Did you guys had a chance to read that Shapiro Stiglitz Fury article or not?
No.
Yeah. So I have put on TechMD. Maybe we could comment. We could discuss that later today because I know this can be a happy hole. But Shapiro Stiglitz theory is a very interesting economic theory that tells, for example, why there is unemployment. Because, for example, it's a great mystery to economicists. Why do you have unemployment if supply and demand holds? So it provides essentially a free market argument of why that holds, and it's very interesting to think that about, let's say, about. I mean, it's a place, it's an example, let's say, where mathematical modeling can provide insights about relationships and so on. But we can discuss that later. And you, Austin, how has been the week? What did you learn?
I spent some time learning about the Ocean Protocol, and I am very interested in trying to scrape some data and maybe publish that. And I did read about the Shapiro-Stiglitz theory, and I did find it really interesting. I wonder what direction you're going to take it. I was thinking maybe it'd be an interesting thing I could try modeling in CAD since I haven't had too much experience in using it, so it might be interesting to try to model that.
Yeah. Yeah, Igaratá is going to be a very interesting project because the way that they are approaching, the best summary that I could give is that they're essentially sort of trying to couple together almost all the technologies that we have on the DeFi space. So any model that is being used on Igaratá most probably is going to be, let's say, very generalizable. I know that because that research group is going to be a collaboration with BlockScience and so on. And yeah, I'm hoping forward to get started. By the way, Thiago, are you familiar with either DX or Ocean markets?
More or less, not so much. Yes. I'm just browsing here the equilibrium unemployment that you just said. I know Shapiro and Stiglitz, but not this particular article. But
yeah. By the way, Xavier and Austin, do you guys feel comfortable in doing a 30-second summary of what is Ocean Protocol, for example? It's a challenge.
Not yet.
That's from what I understand. The Ocean market is trying to connect people who publish data with people who need to use it. And what I remember is that they had some sort of protocol where you can publish data that includes private information, and they have a sort of barrier so that people can use machine learning models and train on that data without actually knowing what is in the data specifically.
Yeah, exactly. It's essentially a marketplace for data. And I mean, it's being already used. It's a project that, let's say, has already taken off. So it's always good to see those examples. And you, Xavier, how has been the week? Something interesting that you did learn and so on?
And I started the intermediate level of CAD course. And I read a little more about DeFi and AMM. And I'm trying to practice, try to implement modern some physical system. I want to see how CAD handle with chaotic dynamical system. I try to modeling a turbulent flow to see what happens.
Oh, very interesting. Chaotic dynamical systems is one of my favorite subjects. What model do you have in mind, Xavier?
I will reading a book, self-organization, and take a look in the models and try to implement. I don't choose any model, but I'm reading and I'll try to implement this.
If you are interested, I do have some dynamical systems demos that perhaps you could use for bootstrapping. Because one tricky thing about CAD is really, because CAD uses a different formalist from dynamical systems. Usually when you try to do dynamical system CAD, there are some patterns that, I mean, once you get used to it, you can do anything. But yeah, very cool. And speaking of dynamical systems, one of the topics that I want to bring in, I'll bring maybe 10 minutes later, is about causal loop diagrams, which is a very general way of, let's say, describing almost any kind of model. It's usually used when you are designing something, but you are on the conceptual phase, where you don't know the exact process, but you do know, let's say, the direction of cause and effect. It's a super interesting topic. It's going to have a lot, but just give it a spoiler. And, well, until Thiago and Raul, do you feel comfortable with maybe speaking something cool that you have learned last week, or some, for example, some interesting problem that you have stumbled into? It's optional, so feel free to skip.
Well, I've been looking into understanding range tokens from UMA and this kind of derivatives option-based framework they have, but I'm still working on it. Also, balancer pool for buyback and stake or something like that. So, sure.
That's cool. Yeah. Balancer. And you, Thiago?
For me, especially along with the Blockchain Research Institute, we are starting to study the, I don't know if you know the work of Elinor Ostrom, the understanding knowledge as a commons. So we're starting to study, and it's very interesting. And in the last week, I've been looking into all the servers from Discord that Danilo introduced me, and I mean, it's a lot of information, but it will take me some time to digest and understand what's going on in everything, but it's very interesting. And I believe it's the closest I have to for the subject here.
Yeah, that's very cool. So we have given ourselves some updates. So I do have some topics, but before going into that, one thing that I always like to ask around here is if we have, usually people like to think about questions and answers, but what we propose here is questions and discussions. The idea is that, for example, you guys may have, for example, an open problem on token engineering, or maybe there is something that you guys want to know better, but couldn't find a pointer and so on. So this is sort of the opportunity, let's say, to ask about anything so that we could discuss. So for example, you, Austin, any, for example, challenge that you have last week, or for example, a certain component or primitive that you wish to understand better?
Not in particular. I was just curious about where you're gonna go with the Shapiro-Stiglitz model.
With the Shapiro-Stiglitz model? I didn't quite understand.
Oh, with the economic model that you showed us.
Okay, the Shapiro-Stiglitz. It's a sort of a bonus content. It's not exactly part of the agent. if you go to the our log, or the Igaratá school log, I'm sending the link here. It's the first link on the session 3, that was last one. I'm saying that because I think it's an interesting, let's say, it's an economic theory, it's a relatively simple economic theory, but it does provide powerful insights. And it's kind of cool to see the argumentation. And there is the thing that a lot of crypto economic systems, they do involve a labor market. And given that, let's say, this is a mathematical specification of a phenomenon, the labor market, this is an interesting ingredient. But it's more of, let's say, I would say it's more of a culture thing rather than a, let's say, a tool that we are going to use on everywhere.
Okay.
And you, Xavier, any primitive or thing that you would like to know about or ask?
For the Omnipool research, they recommend us to study about balancer. I start reading, but there are a lot of systems involved in this project, and I didn't understand the role that balancer doing in this context. I wanna talk more about this system.
Yeah, so balancer, one way of understanding it, it's the graph verse of Uniswap. This is that Uniswap you have, you have the liquidity pools and you use Ethereum as a base one, if I don't, if I'm certain. And balancer is sort of a generalization in the sense that first you can have different weights, and second you can have multiple. The best way that I can describe it is really a generalization. It's a multi-pool, multi-weight generalization. Maybe that's the simple way of putting it.
I understood the mathematical of the thing, but in practice I don't know what's the role in the Omnipool research, for example, of the balancer system.
Yeah. So I'm not exactly the expert on Omnipool, but one use case that balancer is a lot used is for, let's say, is for managing portfolios. Because on crypto, you can have multiple tokens. You want those tokens to sort of track each other. And pools, they do have this function of, let's say, sort of being a place where you can, let's say, have your portfolio. I'm not exactly the best expert on that. If Raul feels that, for example, may have a better answer, it could be good.
Well, they are used. The idea is for having arbitrage traders balance your portfolio. Recent studies show basically that happens, but also a lot of value is extracted from miners. But there are people that are building interesting projects because balancer pool also allows you to change weights and then remove tokens. So you can have, using the primitives of an AMM, you can build, for example, an index. So the liquidity pool token can be a value that tracks several tokens, like kind of like the the indexes in S&P 500 or something like that. In the also, you can have like your DAO's treasury to be more diversified and implement some kind of mechanisms to, you can even launch a token in Balancer, having, for example, 90% of the pool being your token and 10% being DAI or Ether. And you can be changing weights to, create a curve without having to actually write the code for a curve. So it's pretty flexible for a lot of things. I'm not familiar with Omnipool, but probably they wanted you to understand the basics of AMM or more complex AMM for understand their case.
I'm the right path. Thanks.
Thank you.
And you, Danilo, is there, for example, any primitive that you wish to understand better or so on?
right now I am trying to understand a little bit of everything. I think I've been out for 1 weekend. Things are getting a little bit more complicated to understand, but I'm trying to grasp what is going on here first.
And you, Raul?
Basically, well, I don't know if it's identified primitive options, even if they are sort of simple, they kind of elude me sometimes. I don't have interest in the concept, and there's a lot of interesting project that has to do with betting on future values that could be useful to like stabilize a compensation system. So I would like to look into options and how you can do more complex products with them.
Yeah, from a game theory, options is definitely an interesting topic because I mean, it's a way more complex, really, way of doing market signaling. I mean, game theorists love them. I'm not exactly the best person to speak about that, but
well, regarding our ethical, probably the thing I'm trying to understand more apart from that is like relationships between all these, like having part of a liquid portfolio, the stable, like how many projects can we finance with X liquidity locked for X amount of time, plus having some, like basically your model.
Yeah, and also there is always the difficulty because a lot of times this depends essentially on behavioral factors. And on my experience dealing with behavioral models, there are two ways of approaching that. One is to do a really, really complex model that encapsulates everything, but then you need lots and lots of data because you have so much free parameters. And second one is to investigate several simple models consecutively. And the thing is that sometimes, for example, there are circumstances where certain models are more valid than others. Let's say, one thing is to have a behavioral model for a steady state. Another thing is for having, when you have a transition. Steady state is usually simple, but transitions, they are very complicated. In the sense that, I mean...
What do you mean by transitions?
But transitions in the sense that, for example, when you talk about market behavior, because options is essentially market signaling, it's always taught to, let's say, to know how to deal with extreme events, any kind of extreme events, like for example, news, or something that, for example, you have a sudden sale or sudden buy.
In this case, I think it will be easier to simulate just negative, an agent that responds on negative events, whatever they are, with a percentage or something, and just have a range of scenarios maybe.
Yeah, one thing that could help a bit, especially when you are trying to build those kind of behavioral models, is to build causal loop diagrams. I'm going to speak a bit about that. It's a very useful tool for, I mean, at least brainstorming and getting sense of what could make more sense. And yeah. Before going to that, and you, Thiago, anything that you would like to understand or so?
I mean, there's a lot of them, but yes, I've seen in your profile something about the complexity, complex networks, and I'm trying to make sense of that in order to, because in the MBA I will have to make I don't know in English, that's TCC. It's a graduation work. I mean, so I'm trying to make sense of adaptive complex systems to gather ecology systems, ecological landscapes, and the use of big data and artificial intelligence. So maybe something about that would be nice.
Yeah, on my experience dealing with complex networks and especially when with adaptive dynamics, it's usually easier to get a grasp of that actually doing that, because one thing that I feel a lot, it's let's get real. It's somewhat loaded, that word, in the sense that it seems way more difficult than it actually is. So, for example, complex network. What is complex network in, let's say, in practical modeling terms? It's a network X object. What is complex adaptive dynamics? It's a dynamical system that operates on the network X object. As I find that a lot of times it's useful to have that translation layer, because that's a problem on complexity styles in general. You see complexity everywhere and then you think it's difficult, but it's really having a translation layer for the object, getting used to the tools, trying to play with that, trying to, I mean, maybe take a network object and maybe putting a node that hacks to another node by any hand-on hull. It's usually way easier to get comfortable with complex networks by doing rather than by, let's say, trying to understand too much.
Okay, nice. I'll try.
Yeah, if you are interested, Thiago, there is a CAD model that I have somewhere that makes use of network X for doing a certain game. You could say that this is a complex adaptive dynamics, in the sense that you have complex networks and you have a dynamical system and it just interact with each other. I could say to you an example just to see how that looks on code.
Okay, it'll be nice.
Yeah. So guys, I'm going to take the time a bit to speak about causal loop diagrams. I think it's a very useful tool. On my opinion, is one thing that should be taught on schools. Have you ever heard about that? Or Kumu, maybe?
Yes.
And you, Xavier, Austin?
I think in the CAD course, they read about it.
Yes, same, but I've never used it myself.
Oh, that's cool. So maybe it's going to be a bit redundant thing. So I've put on the log a link for a recommended document. This is for a presentation that actually I did on lunch today. That document contains some pointers. We could walk through it, and let me share here. So, given that you guys are already some causal loop diagram, I think that you guys already know the fundamentals. The idea is that we want to map cause and effects. And I mean, they can loop together, and those causes and effects, they can be positively associated or negatively associated. So this is a trivial example of a causal loop diagram in the sense that you have bank balance. Bank balance is a cause of earned interest, which is an effect of having bank balance. So if you increase your bank balance, you increase your earned interest. And I mean, this also causes bank balance. So I would say that maybe this sort of encapsulates almost everything that there is for causal loop diagrams. The only thing is that there are some ways of doing causal loop diagrams. You can be, for example, more rigorous about, for example, the units and so on. So in a certain sense, causal loop diagrams are a precursor of stock and flow. I would say that stock and flow are, let's say, they do have more hurdles than causal loop diagrams. But of course, the main point of why we care about causal loop diagrams is usually because sometimes we want to understand a complex system and we have too much factors and we don't know exactly what are the process, but we can't think about cause and effect. And usually thinking about cause and effect is way easier, because even if you do not know the magnitude, just by knowing the causality order or how, for example, if the loops are reinforcing or balancing, can already provide a lot of qualitative insights about, for example, if one thing is going to explode or not. And yeah, have you guys ever heard about Loopy or Insight Maker?
No.
So I go to show because I think there are interesting tools to note the existence, and also because they can help prototyping a bit. So Loopy, maybe it's just an educational tool. It's really just a tool for, let's say, trying very, very simple things. And the idea is that, let's say, you could use that for creating causal loop diagrams that, I mean, doesn't have complex dynamics behind it. It's really simple in the sense that, for example, you have here, for example, a causal loop diagram for ecology, where, for example, you have a positive feedback from rabbits to foxes, which means that if the number of rabbits increases, then the number of foxes is going to increase. And if the number of foxes increase, the number of rabbits is going to decrease, in the sense that more rabbits means that there are more foxes because they have more food, but more foxes means that rabbits are being eaten. So we could put play here that, for example, suppose that we increase the number of rabbits. So it's going to have sort of this cyclical behavior. So this is sort of a precursor of a prey and predator model, for example. And of course, you could, for example, try to see what happens if you diminish the number of rabbits. And notice that, and by the way, one interesting thing is that the more extreme the feedback is, the more they are going to oscillate. So, I mean, even though it's a very simple system, you can have some pretty non-trivial behavior on that. This is very interesting for you, Xavier, that you are trying to study chaotic systems.
Why is not a predator-prey model? I don't.
Yeah, actually, this is a predator and prey model. If you actually plot that, you won't get those cyclical plots. And by the way, I would even say that, let's say, the point of, for example, using modeling toolkits like CAD and so on is because, for example, we cannot compute metrics about that. For example, what's the typical period of that? Or what's the volatility? Because this is not going to be a clean cycle. It's not going to be a sinusoid. It could be a bit more complicated. So this loop is really something very, it's really a tool for just toying around. But let's say this gets the point of, let's say, the fact that by having those very simple models, you still can have those kind of behaviors. There is also this one about the projection and accent. So let's suppose that I'm going to do a lot of things, and then I'm going to have a lot of fear. Yeah, not so interesting. So as I said, it's an educational tool, but this is a starting point. Another tool that people sometimes use it for causal loop diagrams on a more quantitative context is this Insight Maker. This is a very interesting tool. So this is a tool for system dynamics. You could also do stock and flow modeling on that. It can be very powerful. Sometimes the user interface is not so intuitive, but it's great, for example, if you have a diagram and you want to turn into some quantitative and you don't want to code. So let me pick, for example, some demo. There is, for example, this agent-based. If you go to exploring sites, you have lots and lots of models. So let's see one, for example, about economics. It's taking a while. So while it doesn't run, for example, this is a SIR model. I didn't adopt that. I'll skip explaining that. But yeah, models for SIR. Let me see if there is an interesting one. Why nations fall? This is interesting.
Well, there's a step forward button. Maybe it's like it has slides or something.
Yeah, I don't know why this is not working. But anyway, the demo that I usually like to show is this one here, which is the word tree model. Have you guys ever heard about the word tree? So, yeah, go on. So word tree is a very famous model on the simulation scene, because I think it was one of the first large-scale computational simulations around socioeconomic systems. So the idea of the word tree model is essentially you try to model, for example, the labor dynamics of the worldwide society. You try to model also how natural resources are being used and replenished and also exhausted. You model, for example, how those things also impact, for example, demographic change. The idea of the World 3 model, and also include also factors like, for example, industrial production, and how these also relate to labor and so on. The idea of the World 3 model is really to be, let's say, a sort of a holistic economic representation of the world and also on the ecology of things. This is a very old model. It has at least 5 decades. It was maybe one of the first instances where people used system dynamics to, in a really large scale. So the idea is that, for example, you have, for example, a diagram here that tells how the dynamics of the labor force utilization occurs. So the idea is that, for example, depending on the inputs that you have on agriculture, you can have jobs on agriculture, and this generates some kind of other jobs, and this enter on the job spot. The idea is that it's a very complicated model in terms of cause effect. It really has several parts. And it's kind of interesting because, at that time, when people did build that model, nobody did expect, for example, climate change. And when they did run the model, they had some interesting results. So this is a replica of the original model. And they had actually some quite stark predictions. Like, for example, the idea that population after 2030 would start reducing, that natural resources would begin to deplete quickly about 19, and also that pollution would have a peak on 14.3. And also there is also things about land usage. So they expect, for example, that after the last decade, after the economic crisis, the land fertility would go down faster. And it's kind of interesting because if you take the Human Welfare Index, which is sort of a metric that they have computed, they are saying that the peak of welfare is right now. This is just a coincidence, actually. I just saw that yesterday. But keep in mind that that model was calibrated 5 decades ago. So, lots of things may have changed. But it's kind of curious because when that model was created and so on, people did give a lot of criticisms because, the projections were not optimistic. But they adapt that, let's say, for a lot of things that is related to climate change and land use, they did got it right. So it's just, let's say, a case where, for example, by doing, for example, modeling and so on, you can have, for example, foresee non-trivial outcomes that, if you are observing on the current present state, you are not going to observe. And I have also put here other things related to causal loop diagrams. So, for example, this is an interesting article here that uses causal loop diagrams as a precursor for an actual model for policy making. So on this article here, it's very interesting. The idea here is to simulate what are the social costs of having certain urban interventions according to some cycling infrastructure. And the way that they compute the metrics and also get to calculate the costs and so on is essentially by lay out a causal loop diagram. By having that causal loop diagram, you can, for example, identify some metrics that have economic costs, like, for example, injuries, or let me see. Or, for example, commuting can also have a certain cost in terms of fossil fuels and so on. I'm not going to go too deep on that article, but if you guys want to see a practical application, because in the end, they really get into, let's say, some policy recommendations. It's kind of interesting how they did relate that initial diagram with actual projections and how they did, and also how did they proxy that metrics. So if you guys need any pointer about methodology in general, about how you bring models to practical recommendations, this is a very interesting article. And besides that, one tool that we use a lot for CLDs in general is Kumu. I think that I have already introduced the Kumu before. Are you familiar with that, Austin and Xavier?
No, never see this.
No, me neither.
Okay. So I always tell about Kumu because Kumu is a very convenient tool in order to make those causal loop diagrams. So just to give a quick introduction about it, tool is essentially it's a mapping tool. It's a complex mapping tool. What they usually say, what they say here at the static page is make sense of our messy world. And the idea of Kumu is that you can create those nodes and those relationships between nodes. And it's very straightforward to do that. And this is useful because you can use that for stock and flow diagrams. You can use that for causal loop diagrams. You can also do another thing that I call the concept of causal loop diagrams. Because in order for you to have consistent causal loop diagrams and stock and flow diagrams, you need to have consistent units. This may not be the case. So Kumu makes it a bit easier for you to have, I mean, first think about cause and effect and then proceed to that. So Kumu is one of those tools that I think it's easier to show a practical example rather than try to over-explain. So I'm going to show here two, actually I'm going to focus mostly on these word problems. And I'm going also to show, for example, CLD that we were working today that maybe it's interesting because it gives a practical perspective. So for example, this is a CLD that was done on Kumu. This is a CLD for the word problems. But basically the author did try to identify everything that he thought it was cause and effect. So according to the CLD, he thinks that, let's say, if you start with unlimited group belief, this is going to be the cause and it's going to affect population growth. So just a reminder, the way that you read a causal loop diagram is you always have cause and effect. So the source of the arrow is the cause and the destination is the effect. And so the unlimited growth belief is the cause of population growth, and also it's the cause of economic growth. But economic growth itself is also the cause of unlimited growth belief. So you have a feedback, reinforcing feedback loop. And it's always important to keep in mind that one of the most powerful insights that you can derive from a causal loop diagram is to identify reinforcing and balancing loops. So reinforcing loops are essentially, they are going to explode, and balancing loops, they tend to cancel each other. So for example, you have, for example, a point of explosion here in the sense that unlimited growth belief generates economic growth generates unlimited growth belief, and I mean, things goes on until it explodes. And of course, you could also take the different pathways here. And a more practical example that I want to show, so that was, for example, one causal loop diagram that we were building for the crypto system. It's a very interesting one because what's happening here is that, for example, there is a proposal of, let's say, introducing negative prices on the protocol. And I mean, it's fine, but one thing that is always important to understand before you take the decision is what kind of behavior this change is going to introduce. Is this behavior going to reinforce certain kinds of consequences, or it's going to stabilize and balance those consequences? So just to illustrate here, I'm going to log in here so that I could provide some practical examples. So this is a pretty okay. So for example, just to navigate. So just to contextualize, all nodes here, they are causes and effects. We did a exercise where, let's say, we did try to navigate over all the possible causes and effects related. It's a thought work. It's sort of a brainstorm session, actually. And one interesting thing about those CLDs is that usually when you are trying to create a concept of CLD, it is usually interesting to you to try to list as much as cause and effects as it's possible, because the more cause and effects you put on the diagram, the more you are going to be able to relate different cause and effects that you didn't notice before. And the idea is that doing a CLD usually involves iteration. So you need to have a first iteration. After you do the first iteration, take note, for example, of what makes sense and what does not make sense, or maybe is simply too irrelevant. You start pruning, so that, for example, you remove things that simply doesn't have a strong effect. So this usually goes by iterations. And to illustrate, for example, how this protocol level negative price, for example, could impact the system, we did annotate, for example, some pathways here. So, for example, if we introduce protocol level negative prices, there are several reinforcing behaviors and balancing behaviors that we didn't notice. For example, if we introduce negative prices, we could have even more negative prices because the negative prices are going to collapse the marketplace. This is a risk. And this is not a trivial risk. We only did took note of that when we did the diagram. But at the same time, we also have balancing effects that, for example, if we introduce negative prices, actually, by introducing negative prices, we are going to reduce the negative prices because by having that, we are going to have more clients. By having more clients, you are going to have more demand. But you can also have other things, like, for example, there is a loop here that tells that if we introduce negative prices, we are going to have less negative prices because the supply is going away. Everyone that operates on the system is going away because it's not profitable anymore. This is interesting because, I mean, defining if, for example, a policy, a certain intervention is good or bad, I mean, for example, negative price is a good or a bad thing? If, for example, negative price means that people are going away, then it could be bad. But if it means that you are going to have more demand, then it could be a good thing. So those diagrams helps a bit to thinking about the consequences of taking certain decision points. And also know, let's say, what are the points of collapse? What are the pathways of collapse? So that you can evaluate if this is a relevant risk factor or not. And just to show, for example, how those pathways could look like. So, for example, if we take the less negative prices here, if I click the focus here, it shows, for example, the pathway. I'm not going to explain. Maybe it's not best to me to not explain because there is a lot of context knowledge behind this. So maybe it's going to be a bit overkill. But okay. So those are some examples, and one of the reasons why I introduced that is that Danilo has, for example, already built a stock and flow diagram for at GitHub. So I can open here the log. It's on the, I think it's session 2. Yeah, so I'm going to get here. So I'm going to put here on the. So we already have, for example, a diagram here for at GitHub. So this is sort of, I would say it's a hybrid between a stock and flow and causal loop diagram. But there is one challenge that I would like to pose to you guys. Because, I mean, this is already a quasi-CLD. And the challenge is the following. What happens if you guys, for example, pick those Kumu nodes and those flows, and then put, for example, on one of those two tools here, like Loopy or Insight Maker. For example, we could even try to do that right now. Let me open one of them here. So I'm going to open Loopy because Loopy is very simple to do. So maybe it's the simplest one. But ideally, if we want to do a comprehensive model, we would use CAD or Insight Maker. But for just trying, Loopy can be a good one. So I'm going to share my entire screen here so that we have more view state. So, okay, I have put here side by side the Kumu at GitHub map and the Loopy. This is going to be a very simple toy model, just to see what happens. So let's make a model from scratch. And let's suppose, for example, that we want to see, for example, only the at keys dynamics. So we could erase that. We could, for example, let me see. This is compensation pool. And this is going to be green one. This is going to be cover pool and also green. Auditor pools. Sentence pool. Originator is collateral. And we also have here the internal balancer pool. This is going to be orange. And let's So compensation pool is here, cover pool is here, auditor pool is here, originators is here, incentives is here. And this flow is in. But at the same time, the EMMO balancer can also get back to the originators. And we could also think, yeah, go
on. This one is so much faster. I took so long to do the Kumu.
Yeah. Public. So I'm seeing here at the time. I just thought that we don't have a lot of time, and I want to be conscious of time. But I'm just showing here how you could do it with Loopy. The idea is that you could, for example, simply replicate here the errors and see what happens if you do the system here. But you need also to be conscious that every different color here is a different thing. So, for example, green one are actives, yellow one are DAI, and red one are local currency. And the challenge that I would like to pose is what happens if you do that diagram Loopy and press play? And for example, and what happens, for example, if a public originator is take, or if a compensator is take? If you do that, is the dynamic is going to be trivial or non-trivial? Would it make intuitive sense or not? So the challenge here is really to, let's say, to try to simply copy and paste that model here. And I mean, see if it makes sense at all. I'm going to stop presenting here because, as I said, I still want to leave a bit of questions. I want to be time conscious. So yeah, any comments, guys, or questions about what I have presented so far?
It's okay, so it was very clear.
By the way, if you guys can do it in Loopy, and because I don't know what's going to emerge from that. Suppose that it's complex. Then, if you have a complex behavior, then it's super useful to. I mean, it can get some interesting discussions. But suppose, for example, that the system was sort of trivial. Then, what you could think is what you could add or introduce so that the model, for example, have a more realistic dynamic. Or maybe another thing that you could do is on SiteMaker, for example, it's possible to, for example, to have a more complete interaction. So it could be interesting to explore. I talk through those two tools because I think they are a bit easier to onboard to actual system dynamic models. CAD is way more powerful, but CAD requires more code, requires more technical expertise. And on my experience, we have way more lack of people that can understand system dynamics than people that can do code. It's best to have a system modeler that's good and it's somewhat okay on code, rather than a very good coder that cannot do systems modeling. So that's why I'm putting emphasis, let's say, start it simple and easy. So yeah, any questions, guys, or things?
On InsideMaker, you can do more than just like positive and negative. You can like maybe have some different like equations that.
Yeah, okay. That's possible. InsideMaker is one of the best tools for prototyping system dynamics. Of course, it does have some limitations, but for doing intermediate level models, it can do. So yeah, guys, I think it was a good session. We'll have our session next week. By the way, one thing that I want to leave running on background, as I said, I'm going to do a cycling record on September. So I'm going to run this slot next week and also the week after the next. But probably 3 weeks from now, we are going to need to see maybe another mentor or so on. We're going to see that. I mean, maybe it could be Raul, maybe it could be Sean. We're going to see, but it's going to be interesting because I think that also having different mentors can also give a more, let's say, diverse exposure to, people that have experience and so on. And I think that getting that contact with, all this diversity, I think it's one of the main points of this program. And yeah, hope forward to looking to see you guys next week. Bye-bye.
Bye-bye, guys.
Thank you.
Bye-bye, Danilo. Thank you for having me.
Yeah, you're super invited to come next week. So always come.
Okay. Thank you.
Thanks.